read chapter 4 of Baby Rudin and also did problems in chapter 1. That's what I've done in the last week or so, a little longer for the problems. Did not time myself. I'm only doing that for Abbott. And so if we look at the book itself, this is so there's going to be always a big gap between the problems that I do for Baby Rudin and the reading, because it's sort of the long cycle in this project. I start by reading a Baby Rudin chapter. I read chapters in multiple books. I work out problem sets in all those books. And then at the very end, I do the problem set for that chapter in Baby Rudin. So it's kind of the ends of the cycle. The beginning and end are Rudin, Baby Rudin. Beginning is reading, end is the problems. And so for the problems in chapter 1, I was surprised that I was able to do many of them. And so I'll show them. And then in the case of chapter 4, it's a very short chapter on continuity. And here we go. Continuity. And yeah, it's only a few pages long. Limits, compactness, connectedness, discontinuities. Of course, sine 1 over x, very popular function to show discontinuities. You know, you put in x equals 0, 0, and then sine 1 over x for the rest, and it wiggles very quickly towards 0. Then monotonic functions and infinite limits, and limit to infinity. So that was the reading. Also for the problems, there was some Cauchy-Schwarz inequality problems, and so I had to go back and read in here. I think it's done simpler and better in way than it is in Baby Rudin. So I think I'll do the problems last. Yeah. So this is the reading for chapter 4. And I'm just going to show my notes just for the sake of showing that every now and then I'll draw a diagram. I'm fascinated that Baby Rudin has no diagrams. So it's all about mappings between metric spaces, which means that I'm going to go and read at some point soon chapter 13 in Thompson, Bruckner, that does a lot of metric spaces. So there's this whole subsetting business of using E as a subset of the metric space X, and then being able to do a round trip, be able to do round trips. And of course, the difference between continuity and uniform continuity: if it's uniformly continuous, it is continuous, but not the other way around, unless you're talking about a compact set. Drew it just so that I could understand what the graph looked like. Of course, splitting into two sets to show that to show a contradiction by showing that something is not connected when it should have been. Yeah, proofs by contradiction work really, really well. The monotonic functions. So that was chapter 4 reading, and then for problems. I should show the back, of course. I forgot to show the back. So of all the problems, actually I thought I realized that I could do this problem that the first problem, which is to show when you add or multiply rational and an irrational, you always get an irrational. I thought of doing it as a proof of contradiction. Woke up one morning and I was like, hey, I should do a contradiction proof. So actually this solution that I have here is different from the one that I did for when I did it in Bardow and Sherbert. Then I ran through all the problems, and only 7 and 20. 20 is the one problem about cuts, about Dedekind cuts in the whole problem set. And 7's got to do with powers, the logarithm function. And I read it and I started working on it, and I was like, you know, this is an interesting problem. It's going to take me a long time. I'm going to punt and move it to later. So yeah, so these are the problems that I attempted. Well, I attempted all of them, but these are my solutions. I'm sure I made some mistakes. I'm sure there are some better ways of solving the problem, but it felt doable, which is great. At first I thought, well, by the time I get to the chapter 1 baby Rudin problems, they're going to be like super difficult, and that wasn't the case.